In example 2, we're asked to order rational numbers from the given set that we're given. And if you'll notice in the given set that I've gone ahead and written down, they're all in different formats, or we have 3 different formats. We have a decimal, we have fractions, and then we have a percentage. We need to convert them all to the same format. If we use fractions, we'd have the additional step of having to put them all over common denominators. So what I would suggest doing is, if you have a decimal and fractions and a percent, let's just go ahead and write them all as decimals. So we start off with, we're given negative 0.25 or negative 25/100ths. Let's go ahead and rewrite all of the others as decimals as well. So negative 1/3, we know the solution is going to be negative. And to convert a fraction to a decimal, remember, all we do is use long division. So we know the solution is going to be negative. So I'll go ahead and put a negative out here. And then 1 divided by 3. So we know there's going to be a 0 here because 3 will not go into 1. So we start off with 10. 3 will go into 10 3 times. And that's going to be 9. 10 minus 9 is 1. Bring down your 0. And we end up with the same thing. 3 goes into 10 3 times. And this is just going to keep repeating. So we know it's just dot, 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 dot. So this equals negative 0.3 repeating. 1/4. Go ahead and use a different color here just to differentiate. So 1/4. We should know this at this point, but if we don't recognize that 1/4 is 0.25, we can always use, again, long division. 1 divided by 4. 4 goes into 10 2 times. 8. 4 times 2 is 8. 10 minus 8 is 2. Bring down to 0. And 4 goes into 20 5 times. So this equals 0.25. 3/5. If we multiply that, both the top and bottom, by 2, we end up with 6/10, which as a decimal equals 0.6. And again, you could also use long division. 7/9. We just looked at that in a previous problem, but we'll go ahead and write that out as a long division problem. 7/9. How many times will 9 go into 70? That would be 7 times. 9 times 7 is 63. 70 minus 63 is 7. Bring down your 0. And we have a pattern of 7 as our remainder. So this equals 0.7 repeating. And then last but not least, 23%. We just move the decimal place 2 places to the left. And we know that that's 0.23. So if we just rewrite the set as what we just determined, we have negative 0.25, negative 0.3 repeating, 0.25, 0.6, 0.7 repeating, and last but not least, 23% is 0.23. So let's go ahead and order those. If we order those numbers, what is the smallest number? Well, we have negative numbers, so what's the most negative? The most negative is negative 0.3 repeating. Remember, if it's bigger in the negative direction, that means it's less than, because it's further to the left in the negative direction. And then our second negative number is negative 0.25. Let's go ahead and mark these off as we go. And now we order the positive numbers. The next largest value is 0.23, then 0.25, then 0.6, and then 0.7 repeating. And then we just change the values back to what they were. So negative 0.3 repeating, that's negative 1/3. Negative 0.25, we were given that in that form, so it goes down as negative 0. Actually, I'll write it as what we originally started with since we were given that. Negative 0.25, and then 0.23, that was our 23% right here. So we'll rewrite 0.23 as 23%. And then our 0.25, that was our 1/4. So we'll rewrite that as 1/4. The 0.6, we were given that as 3/5. So we'll go ahead and write that as back as 3/5. And then finally, our 0.7 repeating was originally our 7/9. So we'll replace the 0.7 repeating with 7/9. So from least to greatest, negative 0.25, negative 1/3, 1/4, 3/5, 7/9, and 23% would be negative 1/3, negative 25 1/100ths, 23%, 1/4, 3/5, and 7/9. And if we really wanted to check this, we could take our decimals, make a number line, and then plot them on the number line as well.